Quick disclaimer before we begin, the PEMF podcast does not contain any medical advice, and the content provided is for informational purposes only. If you have any health concerns, please visit a healthcare professional. Welcome back to another episode of the PEMF podcast, and today we are joined by Christian Drapeau from Stemregen, and I'm really excited about this episode because we actually met a few months back at the Alma Frequency Festival in Ibiza. And, you know, I believe in things always happen for a reason. So this podcast has been kind of a long time coming since then. We started talking all things stem cells. So Christian is an expert in stem cell and stem cell research. So we'll take a deeper dive today into this and how that can link with PEMFs, because NASA was also looking at PEMFs in increasing stem cell growth, and they looked at increasing those growths by about 400%. So let's start with Christian. If you can introduce yourself and just give us a little bit about your background, if that's okay, please.
Okay. Well, my background is neurophysiology. So essentially, my training in the whole world of medical research was at the Montreal Neurological Institute, brain research. So I was working on epilepsy and memory. And in the early, not even early 2000, mid-1990s. So 1995, I was hired by a company selling Klamath Lake blue-green algae. To study the mechanisms of action, active compounds, like how this plant was working in the body in order to support any of the claims that they were using. And that research effort led to the discovery that this plant had an effect on stem cells. It was triggering the release of stem cells from the bone marrow. So from that point on, so that discovery was essentially early 2021. So since early 2021, I've been working in the field of stem cell research, just developing ways of stimulating stem cells in the body.
Mm-hmm. And what is it? What's your position now?
Right now, I'm the founder and chief science officer for Stemregen.
Mm-hmm. Okay, cool. And I had an incredible experience with Stemregen because anyone that follows me on Instagram will see that about 6 weeks ago now, I was hanging a mirror and I cut the tip of my finger off. And one of your team contacted me. They sent me some Stemregen. And obviously, I use PEMF on a daily basis anyway. So my recovery rate is quite quick anyway, but I wanted to see if I can extend this and get any better results. And I was absolutely amazed. I mean, we'll try and link together some before and after photos of my finger. But in 4 weeks, it's completely healed and you wouldn't even know it had happened. So that was my kind of first experience of Stemregen and stem cell therapy. And yeah, as I say, we'll link that underneath this. But when was the first time you ever heard of stem cell therapy, Christian? And what was that point? And what did you think at that point?
I mean, I was in the very, very early days of this whole field. So for me, it did not even start with stem cell therapy. It started in 2001 when I came across an article. And just before that, we need to understand that stem cells have been known for decades, probably since the 1950s, early 1960s. That stem cells were precursors to blood cells in the bone marrow. They make red blood cells, white blood cells, and platelets. That's what we learned in school. So early 2001, I came across an article documenting stem cells leaving the bone marrow, going to the brain and becoming brain cells, which was, I mean, to me at that time, quite an observation, because it was basically challenging two known traditional dogmas. Stem cells can only become blood cells, and the brain does not repair. And here, a stem cell was seen going to the brain and becoming a brain cell. So I thought it was very interesting. So I went to the local medical library and see what else I could find. And I found another article documenting stem cells going to the liver and becoming liver cells, and another one describing stem cells going to the heart. So I thought, if stem cells can become heart, liver, and brain, why not pancreas, lung, skin, and the rest? Makes no sense. Like, I cannot imagine or think of a physiological process in the body that would make stem cells become heart, liver, brain, but not the rest. So I assume that let's assume that in the coming years, scientists will discover that stem cells can really become anything in the body. And if we assume that that's the case, then stem cells must be the repair system of the body. So we published an article in a journal called Medical Hypotheses suggesting that stem cells are the repair system of the body. And in the back of my mind, that plant, that blue-green algae I was working with, what is if it was stimulating the repair system of the body by triggering the release of stem cells? So these were like two far-fetched hypotheses, but we bought the equipment to count the number of stem cells in the blood, and we discovered that That's what this plant was doing. So that was before all the ways of using stem cells for treatment. So I don't remember when I heard about using stem cells as an injection, if you want, but it was definitely in the world of research, like years before it was used clinically and available for people.
Okay. So sorry if you touched on this already, but I want to kind of reel it back a little bit and just define what is a stem cell, because it's being used, that term is being used quite a lot in the biohacking industry at the moment. And as you mentioned, which we'll come on to, people are injecting them. And we understand that stem cells are there for healing, that sort of thing, but breaking it down as basic as possible as you can, what is a stem cell?
Okay. First, let me just put all of this in context. Whenever you discover something that is new, like and extremely powerful, it makes the mind immediately go and try to find this in those rare places where you can find it, like dark matter, God particles. Like we discover them like in this interstellar space. Oxygen. Let's say we discover oxygen, and we find oxygen in some rare area. And then suddenly over time, you realize that oxygen is everywhere. Dark matter is absolutely everywhere. It's the space that we live in. It's the space in the atoms of our cells, of our body. So it's like absolutely everywhere. We bathe in it. Stem cells are a little bit the same. So first we discover, there are these rare cells in the bone marrow. We can find them in the embryo, before 8-10 days old, before the embryo gets into a fetal state. So 8 to 10 days old embryo. Then we find some in fat tissues. We have some in umbilical cord. Now take a distance 25 years later. They are everywhere. Stem cells are everywhere in every single organs in the body, tissues of the body. They all have this population of cells that meet the definition of a stem cells, which is that it can self-replicate, it can multiply, and it can transform into another type of cells. That's the definition of a stem cells. And to understand what that means, we need to define what is not a stem cell, which is every cells of the body are somatic cells. They're cells of your brain, of your retina, of your skin, of your lung, of your pancreas. A cell of a muscle will contract. It's the only thing that it's going to do. Cell of your retina will be excited by light and will send an electrical impulse. That's the only thing that a cell of your retina will do. They're specialized. They never transform into anything else. At the other end of the spectrum, you have stem cells. They're almost like a blank cells. They're nothing until they start to transform into something else. And it is in this process of transformation that they play their role as the repair system of the body. And then they leave the bone marrow as really a blank stem cell. And as they migrate or travel in the body, they transform into what is called progenitor cell, which is a little bit of a stem cell that has taken a step to become a heart, a brain, a lung, a liver, blood vessels. And now they become progenitor cell, which is more of a cell that belongs to a tissue in your body. So they're everywhere, but to answer your question super simply, they're blank cells that have the ability to multiply and become cells of other tissues.
No, brilliant. Thank you for that. It was a great summary. And is there any kind of main misconceptions when it comes to stem cells? Anything that's out there that you see often that is misconceiving stem cells in this industry? I
mean, a week or two ago, again, I was in a discussion, which honestly, I never thought those kinds of discussion would happen, but I live a little bit in a bubble. I live in my world of stem cell research in a way. And I was just flabbergasted of talking to somebody in a position, a regulatory position, and overseeing our products and basically saying, you cannot make a statement that stem cells can repair tissues because only embryonic stem cells can do that. And I was just like, how can we still hear something like this in 2025? There are thousands of studies published in the scientific literature really documenting that adult stem cells from your bone marrow can transform into cells of virtually any tissue, fat cells, umbilical cord stem cells. I mean, many, many types of stem cells that are available can transform into various tissues. So I would say the biggest misconceptions right now is that really the true repair can take place with embryonic stem cells, not with adult stem cells. Absolutely untrue. And the second misconception is that if you really want to tap into the potential of stem cells, well, the other one is that stem cells don't work, because there are people who get stem cell injection and they report that, it has not really helped them. And I think what I respond to people who bring that up. Let me one step before. Oftentimes in lectures, I show a video which is a group of scientists who took the heart of a mouse, completely digested the heart, so that at the end they're left with only the connective tissue of the heart, like the collagen of the heart. And on that connective tissue that still retains the trace that it was a heart, they place stem cells from the same animal. And about a week later, they have a beating heart in a test tube. Just to show like the raw power of stem cells is absolutely phenomenal. So to me, the question is, what is it that was done or not done in a study or in a treatment that did not foster the ability of stem cells to really express their phenomenal raw potential? So it's the misconception that stem cells don't really work. They absolutely work. We just need to find a way in every individual to really make them express this raw potential. And the third one is that the only way to tap into stem cell potential is to go to Mexico, Panama, Costa Rica, or somewhere where you can get an injection of stem cells, with people thinking that they've been now exposed for the first time in their life to the power of stem cells, while they are born with it. It's been in their bone marrow since the day they're born. You had a cut on your finger. I'm sure it's not the first injury that you've had in your life. And you have witnessed they've all repaired. All the injuries that you've had in your life have repaired. And they repair because your body has a repair system, and that's your stem cells. Your stem cells have repaired everything in your life since the day you're born, and they're keeping you alive today. So stem cells are way beyond just a treatment. So to me, I would say like they're the three main things that are still remnant out there on the marketplace, like in people's mind. And that's why I do this podcast and I keep lecturing.
Yeah, no, that's good. And you mentioned that as a key part of a treatment or recovery process, but how important are stem cells for overall health and aging as well? Do they play a part in that?
In health, they play a huge part, because in most of the time when we talk about stem cells, we talk about repair. So they go in the body and they repair an injury. But when there's nothing to repair and no injury, like right now, your finger is healed, you're fine. Your stem cells are still doing a crucial role in the background, which is replacing the cells that are being lost. You have heard, many people have heard this sentence, you get a new heart, a new body every year, every 5 years, 7 years, 12 years. The reality is that you don't have a new body every such amount of time. It's that every single organ and tissue goes through its own turnover cycle, with a specific turnover rate. You get a new liver every 2-3 years, a new skin every month. Even the heart that was believed to kind of build up until about 8-10 years of age. And after that, whatever you have is what you have. You talk to a traditional cardiologist and they will tell you your heart cannot repair. While we know today through stem cell research that the heart goes through a turnover rate of roughly about 1% a year, which is significant. So even the heart will renew, let's say half of your heart every 25 to 50 years. So everything is in turnover. Turnover means you lose cells. So if you want your heart to stay healthy, stem cells must go in the heart and replace the cells that are being lost. So in the background, stem cells play a crucial role in the health maintenance. The real issue is that we're born with red marrow that makes stem cells. Very quickly in our lives, it transforms or converts into fatty marrow that does not make stem cells. By age 30, we've lost about 90% of our red marrow. So we are subjected to this, or we experience this very drastic decline in the number of circulating stem cells, which means the number of stem cells available to participate in this process of tissue maintenance. So somewhere in our 30s, early 40s, we start to realize we don't recover as fast as we used to. And as we keep growing, not growing, but aging, we start to develop age-related problems, which are all linked to the fact that you don't have enough stem cells to, let's say, renew your pancreas. So you develop diabetes. To renew your brain, so you develop Parkinson. To renew your lung or injuries to your lungs, so you develop emphysema. So I published this view about 10 years ago in a journal called Stem Cell Research and Therapy, suggesting that the fundamental cause of the formation of age-related diseases is this decline in stem cells. And at that time, I said there are ways to look for this. Let's go and study and quantify the number of stem cells in the bloodstream of people who have developed various kinds of age-related disease, and let's compare that with healthy people of the same age. And right now, across the board, you look at heart disease, vascular disease, overall cardiovascular disease, atherosclerosis, high blood pressure, erectile dysfunction, liver failure, diabetes, kidney failure, emphysema, skin problems, Alzheimer's, Parkinson. The list keeps growing. Even obesity, even migraine has been associated. So people with these problems have on average 50% or less than the number of stem cells that you find in a healthy person. So you take everything that I just shared right now and put that into the bigger context, the health that you have at 30, your most powerful way of keeping it that way for the next decades is to make sure you have enough stem cells in circulation to offset this acceleration of cellular loss taking place as we age. Mm-hmm. So stem cells play an absolute crucial role in just like your overall health at any point in your life.
Yeah. And like you say, it's common knowledge that as you get older, you start to repair less or less quickly, so to speak. Mm-hmm. And that's a direct, correlation to the stem cells. Do you believe there's a way that we can stop this decline or reverse the decline in stem cell reduction as we age?
That's the big question. Right now, if I had the cash, when I have the cash to fund this kinds of work, mm-hmm. to me, probably the biggest discovery in the whole world of anti-aging, longevity, science is going to be finding a way to slow down this conversion of red marrow into fatty marrow, or even lead to what is known as reconversion. And when I say I have the cash to do it, is because the moment you start to do this, you're kind of peeking into an area that is, I wouldn't say problematic. It's risky. Like we need to do tons of safety studies around it. It's because right now, the only time that reconversion has been documented in human health is when somebody has leukemia. So we have to study very carefully ways that will trigger a form of reconversion that is a true regeneration of the red marrow and not a disorganized explosion of your red marrow that is essentially leukemia. So, but research in that area, slowing down this conversion, triggering this reconversion, or in the meantime, which is really the field that I'm involved with, whatever you're left in terms of red marrow, make that produce more and release more of stem cells. That's really what right now the only strategy that we can tap into.
Yeah. Okay. Cool. So looking at more about what stem cell therapy can help with, something we call kind of a bit of a problem with PEMF therapy is it helps with pretty much everything, because you're treating the body as a whole, you're treating the cells, you're creating an environment to heal. Effectively, that's going to have a positive and beneficial effect on everything within the body. So, people always say to us, what conditions does it help with? But is there something in particular that you would say that stem cell therapy is particularly strong, more so in one area than another, in terms of like, is it better for injuries? Is it better for, or is it like, again, an overall tool?
It's both. You saw it. You had an injury, and you see the acceleration of the process of tissue repair. Now extend that injury to anything. So anything that is a tissue that is not functioning normally, it is calling for repair, and it's not repairing because you don't have enough stem cells to really accomplish full repair. The moment you give the body more stem cells, the body will use them for tissue repair. Example, we are right now doing a study with stable chronic congestive heart failure. The study is not over, it's ongoing. But of the 10 patients so far with stable chronic congestive heart failure, when we give them a blend of plants that triggers the release of their own stem cells every day, 3 times a day, after 6 months, these people that had stable chronic congestive heart failure, so wherever they were, after 2 years is whatever medicine could do with them. And 6 months later, they have recovered normal heart function. So just to show that if you can put more stem cells in circulation, tissues that are known to not repair easily can repair. Now extrapolate that to anything else that can repair more easily, and you can see those benefits. So it's really touching just about everything in the body. Although most people start paying attention to stem cells when they have a problem and they want to resolve it. We need to understand that 95% of the problem that people experience globally is not something that has happened on the day that they start to pay attention to it. It has evolved over a number of years. It's a slow decline until the day that it crosses a line where it becomes diagnosable and it starts to affect their quality of life. Now they start to think about it. It's more difficult at that time to reverse it. That slow progression could have been reversed before that simply by having more stem cells going and replacing the cells that are being lost and replenishing those tissues and organs with more stem cells. So it is for repair, but if you think about boosting your stem cells before you have the problem, it is probably the strongest tool for simply health maintenance and aging, with overall health, which is a lot of what PEMF is used for as well. And I want to bring that in because there's an amazing synergy. I would surmise, not 100% of it, but a lot of the benefits of PEMF is actually stimulating stem cells in the body. There's nothing in your body that repairs without tapping into the repair system. If you have a cold, the best way to handle a cold is to do something that is going to boost your immune system. And if there's something that you do that helps you recover from a cold, it's because it has supported your immune system in one way or another. If something is good to help you repair, it's because it is leveraging stem cells in one way or another. And PEMF, to a large extent, works through stem cells. So they're very similar and very synergistic, if you want, in the way that they work.
Yeah. And we'll touch on the kind of combo soon. So, because it's a really interesting thing. And there's so many different synergies, like you say, because, a lot of people also introduced to PEMF because of an injury. It's your way of tapping into these different therapies a lot of the time. And, the first time I started to use Stemregen was because I cut the end of my finger off and it was trying to, see if I can heal it in a much quicker time. So, we'll talk about that a bit more in a minute. But we've touched on it on this episode already about injecting stem cells, and we had Chris Gethin on our podcast, and he mentioned during the time also he had injections for stem cells, and quite often Joe Rogan talks about it. He mentions going down to Mexico, getting injections. But when we started talking over dinner, you were talking to me about yours is it's an ingestible, so it's a supplement, which I've got one here, one of the tablets. And when I was using it, it was taking 2 tablets 3 times a day, and so obviously it's a lot easier than injecting it into the body. So what are the main differences? Because I think most people, when you mention stem cells at the moment, will just assume from the get-go that it's an injectable. You see in these NAD plus and all that sort of thing, and it's a lot of injectables are becoming more common. So what are the main differences between the supplement versions, the injectables, and is there benefits to one over the other?
I mean, it's a big question, and I'm sure you'll get different answers speaking with different people. I'll try to give you a truly objective answer, although it will be easy to think that I'm biased here because obviously I created Stemregen. First, just to be clear, Stemregen is not stem cells. It's herbal extract that will trigger the release of your own stem cells. So you take 2 capsules, and what we have quantified using flow cytometry is that if we count stem cells before and after, within 2-3 hours, you will have an additional about 10 million stem cells in circulation. So the big difference, and let me put first all of this in context. Early 2000, the belief was that your own stem cells from your bone marrow are not really true stem cells. They're not really having the ability of becoming cells of various tissues. The data was in the scientific literature. If you really looked for it, it was there. But overall, general population, this was not known. So people started to look for other source of stem cells that would be more potent than your bone marrow. So immediately, placenta stem cells, umbilical cord stem cells, embryonic stem cells, but they have a too high risk of developing tumors. So they've not really been used in treatments. So if you talk about umbilical cord stem cells, then that means you need to develop networks of collections. So it really developed, and then we found stem cells in fat tissues that were effective. So collection of fat tissues, extracting of stem cells, growth of these stem cells, it developed into these huge networks of collection and then distribution and then application of these stem cell injection, which to a large extent for X reasons are not easy to do in the United States. Legal or not, oftentimes it's not that they're illegal. It's just that part of the process is not partly illegal, but there's a lot of pressure you'll be investigated. So a lot of people just don't want to touch it. So you have to go to Panama, Costa Rica, and other places to get them. And as all of this is being developed, we realize that stem cells from the bone marrow actually are just as effective as a lot of these stem cells. You just need to use them in a way that maximizes their benefit. And then along the way, we realize that, you know what, you're actually releasing these stem cells every day. And there are ways to boost their release. So now, if what we know today was there 20 years ago, I believe that maybe the whole field of stem cell injection might not have developed the way that it has. Because you take 2 capsules, for example, of Stemregen, you release 10 million stem cells. You do this 3 times a day, you've released 30 million stem cells on that day. Do this for a week, you've released 200 million of your own stem cells. So it starts to be very significant in a short amount of time at a very, very small cost compared to an injection. So now let's compare the two. You go to get an injection of stem cells. If you get umbilical cord stem cells, they're young stem cells. They're more effective than your bone marrow stem cells. So now it becomes a balance of saying, if I get an injection of young stem cells that are stronger, is this one-time injection more powerful than me releasing my older stem cells, but I can do this over months and months, years, where I release these stem cells every day. Second, if I go for a stem cell injection for one application, I don't know, an injury, or my diabetes or whatever, I go for one application, but in our lives, you go to the gym, you have injuries, you cut your finger. Like there's a lot of things that happens. A product like Stemregen gives you access to boosting your ability to repair in many, many different factors of your life, not as just a one-time injection. What we see in our studies is that when you combine both injection of young stem cells that go back to the bone marrow and then you boost their re-released from your bone marrow, you seem to get a much stronger response, or I should say greater benefits over time. So it's a combination of both is probably the strongest. If you can afford it, go. You can go and get a stem cell injection. It's fine. But in a way, I believe that over time, as you stimulate your own stem cells every day, the cumulative impact will end up being superior over time just by releasing your own. And at the end of the day, if you can't afford it, you'll go and you'll do it. So it's fine. I would say if you can't afford it, do both. It would be foolish to have a stem cell injection without following it by triggering the release of your own stem cells. You're missing out on one of the greatest component of stem cell injection, which is the fact that you're repopulating your bone marrow with another strain of stem cells that you want to re-release because they're younger and they're stronger if they are umbilical cord or even fat tissue stem cells. If you can't afford it, then you can release your own and you'll get all the benefit of your stem cells over time. Yeah. So that's probably the best way of summarizing all that science.
And it's quite a similar comparison to PEMFs because they characterize it a lot of the time in low intensity and high intensity. Low intensity is more like a daily continuous treatment. High intensity would be once a week, twice a week, big shot, and you don't need it as often. So we can kind of break it down like that for our listeners because we talk about high and low intensities quite often. But there was something you mentioned at the beginning of that answer that your supplements don't contain stem cells. So I just wanted to kind of come back to that. What they do include is ingredients that inhibit a response from the body to create the stem cells. Do you have an easy way to explain how that happens? Because obviously if I cut my finger, my body kicks in, stem cells are released, it heals. How do the ingredients within Stemregen inhibit the same response?
Okay. It's not inhibits. It's more like elicit because there's inhibition, there's stimulation, there's different. So it's not a simple answer, but I'll try to make it as simple as possible. Just like, there are fast mimicking compounds that will trigger cellular autophagy, which is a phenomenon that is normally seen when you fast. So they're called fasting mimicking compounds. So it's a little bit the same thing. There is a process that is triggered in your body when you need to repair. The target of this process is a reaction that is called SDF1 CXCR4 axis, which is a receptor on your stem cells that is very specific to a compound called stromal-derived factor 1, SDF1. When these two connect, it makes your stem cells cling to the environment wherever it is. If it's an injury, your stem cells is circulating into your fine blood vasculature, and an area where there's an injury, SDF1 is released. When that connection takes place, the stem cell cling to the capillaries, migrate into that tissue, and do the repair in that tissue. In your bone marrow, that signal that is normally done by an injury is always in your bone marrow. So when a stem cell is released, if it does not go to an injury, it's recaptured by the bone marrow. So your bone marrow is very active. So if you disrupt that connection in one way or another, you will trigger stem cell release. So your natural response is that you will trigger an injury will trigger the release, the synthesis, the production of certain compounds like granulocyte colony stimulating factor, GCSF, stem cell factor, interleukin 8, different factors. When they reach the bone marrow, they will collectively lead to the secretion of an enzyme that digests SDF1. So if SDF1 is digested and you no longer then have that connection, so the stem cell loses its adherence to the bone marrow matrix and it gets caught into the blood circulation. So we have in the blue-green algae, the first plant that we have documented. So it's a plant where I saw benefits like people reversing insulin-dependent diabetes, the consequence of heart attack, liver failure, severe emphysema, Parkinson. So I could not explain how one plant had benefits touching so many different aspects of human health. So when I made these first observations in the scientific literature about stem cells, I thought maybe this plant triggered the release of stem cells. It was a crazy idea, but it was the only one that makes sense to me at the time. So we bought a flow cytometer to count stem cells, and then we quickly discovered that this is what that plant was doing. So it was triggering the release of stem cells, and we discovered that it was doing this by not digesting SDF1, but by suppressing the expression of the receptor. So now you have SDF1, but if you don't have the receptor, stem cells get detached from the bone marrow. So that's the blue-green algae. We have compounds like panax-notogensin. Panax-notogensin will make your body secrete stem cell factor, and then will reverse the gradient of SDF1, which is higher in the bone marrow, lower in the blood. And within about an hour or two of taking panax-notogensin, SDF1 decreases in the bone marrow and increases in the blood. So now the stem cells are attracted to your blood compared to your bone marrow. So you get a mobilization of stem cells to the blood. So that's how this plant is working. Other plants like sea buckthornberry tend to do like fasting mimicking compounds. It increases the concentration of GCSF into your blood. So it makes your body react as if you had an injury, but you don't. You just ate a berry extract. Mm-hmm. So these are the different mechanisms of action that lead to us quantifying in the bloodstream more stem cells in circulation.
Okay. No, it makes sense. So one other question that I wanted to ask is, and tell me if this is a stupid question, but are there more than one type of stem cell? Are there different type of stem cells in the body? Because I know you have different within Stemregen, you have release, and then you have like sport and different compounds. So, are there more than one type of stem cell? And if there are, is it better to inhibit more than one to create a better kind of healing effect? How's that working?
Yeah. I mean, that question, you can go pretty deep in the rabbit hole, because the way that how can I make that answer simple? So in the world of stem cell treatments, the stem cells that people are looking at, which is probably your question, like which one do I take? Do I take fat stem cells or umbilical cord stem cells or V cells? These are like the ones that are the mostly commonly available right now. They're all effective. They're all working. They're different. So mesenchymal stem cells, bone marrow stem cells, you all identify them with using different markers. I don't know if it's the right way to take this discussion. You have umbilical cord stem cells, fat stem cells, V cells. You also have endothelial progenitor cells, which is a stem cell that has started to go into the direction of becoming blood vessels. Stemregen, when you take this blend of plant extract, we have documented an increase in V cells, small stem cells, mesenchymal stem cells, endothelial progenitor cells. These are the main stem cells that we want to use for repair. Mm-hmm. Down the road, these stem cells can become progenitor cells. They move in different tissue. They become all kinds of different cells. Is that sort of answering your question? I'm trying to find which direction I should go. And I'm realizing as I'm going down, so I'm going to go into like a dead end here that will be too complicated and won't really answer your question. Available in the market.
Go on. In more of a terms of, with your different supplements you have, is there one that you recommend to take for certain times for, so I cut my finger, I was sent release. Is that the right one I should be taking for recovering of that injury? And the sport performance and that sort of thing, what are they doing differently? Are they inhibiting different stem cells?
So if the question is about the product line that we have one product, two products, release and sport, that will do exactly the same thing. The only difference is that sport was developed with an additional ingredient that supports the repair of joint, muscle, tendons, the issues that somebody who works hard, an athlete, is going to face. And we're able to certify this product with NSF. So it is certified to meet WADA regulations, so it can be used by professional athletes. So, but in the body, in terms of stem cell release, they act in the same way. They will release bone marrow stem cells. They will increase the number of V cells, which is small stem cells, which are really probably the most potent stem cells in the human body, at least of what can be utilized right now. They're extremely potent, the most pluripotent in the body. And we also increase endothelial progenitor cells, which are the cells that have been destined to become blood vessels, because a development of a healthy microvasculature is absolutely essential for optimal health. If you take a blood sample and your blood is perfect, it doesn't mean that you're healthy, because that blood needs to reach absolutely every single corner of your body. So it depends on a good microvasculature to really go everywhere. So you need to have good microvasculature. So that's what endothelial progenitor cells will look like. So when I said that there's a link between all age-related diseases and the number of stem cells in circulation, a lot of these studies have linked that to actually the number of endothelial progenitor cells. The cells that are capable, they're all capable of doing it, but the one that have started to go into the direction of becoming endothelial progenitor cells. So release will do that, release and sport. What we have seen, us, but also everybody in the whole world of stem cell injection, you will get 30% of your people who will say, man, this product changed my life. My cut just healed like so quick, like it works. Then you get about 30% of the people who will tell you, I got really good benefits, but I was expecting more. Like I didn't get all my wish list. And then you've got the people who would say 30% will say, I didn't get any good benefit from this product. It was a waste of time. We need to understand your stem cells are your repair system. Whether it works well or not, whether there's something standing in the way for the full expression of this repair power, it's in your body and it's working. Otherwise, you would be dead today. If you've got a new liver every 2-3 years and you're 50 years old, 40 years old, 30 years old, and you don't have liver issues, it's because your stem cells are working. So the question is, why are they not working for the problem that I have that doesn't seem to be repairing very well? So two reasons are standing in the way of stem cells to work in that area. Is that area, because of its chronic nature, the problem, oftentimes it's been afflicted by poor blood circulation, poor microvasculature because of the chronic inflammation in that area. So we want to optimize the delivery of stem cells to that area. Stem cells can go up to 20 micron. A capillary can be 12 microns. So for stem cells to enter this capillary bed, a lot of things need to line up. So we've created Mobilize. So it's a product that contains nattokinase that will increase blood fluidity so that stem cells can be more easily entrained everywhere in your body. We have nitric oxide producers to dilate arterioles to increase blood flow to the capillaries. But that blood flow does not really increase properly if the capillaries cannot extend effectively. So we have bioflavonoids and compounds, herbal extract that have been documented to help the structure of the capillaries, all the collagen, all the connective tissue around these capillaries to give them good flexibilities. And we have added polysaccharides that help rebuild the glycocalyx, which allows cells to really flow freely in capillaries. So Mobilize will help rebuild the capillary bed to allow optimal circulation of stem cells in that area. But in order for stem cells to recognize that area is where they need to go, you need to suppress systemic inflammation. In a lot of 50-year-old, or whatever the age, you get up in the morning and you start to have like ache and pains in different places. That means these are places of inflammation in your body, and they're there every day. So they're leaking. So there's oftentimes, it has built up a background of inflammation called systemic inflammation, silent inflammation, and it fools stem cells. Stem cells, it's like you trying to find, right, to listen to, I don't know, you want to listen to your phone call where you're in a bar where the music is super loud. You cannot hear. So stem cells are deafened by overall systemic inflammation, unable to hear where the real call is coming from the injury or the place that needs repair. So we have developed signal that is a blend of plant extract that are reducing the secretion of various inflammatory compounds coming from various inflammatory pathways. Block COX-2, so inhibitors of COX-2, 5-LOX, the secretion of various inflammatory cytokines, bromelain to digest existing inflammatory cytokines, and so on. So that you suppress systemic inflammation, you open the blood vasculature, and now the stem cells that you have released with release or sports can easily find access where they need to go. So you give them a greater chance of doing their job in the body.
No, good. Okay, makes sense. And on top of that, someone's just come to you and they've said to you, right, well, I'm gonna start taking Stemregen, or I'm gonna do some kind of stem cell therapy. Is there anything? So we'll move on to the tech after this question. But is there anything that can inhibit the results and get better results alongside? So I'm talking more about diet. There's people that say fasting with stem cell therapy, all these sorts of things. Is there anything that you kind of recommend to people to get the best out of their stem cells?
Yes, there are ways to release stem cells. So fasting will release stem cells. Hyperbaric chamber will release more stem cells. Meditation, although it was not published in the scientific literature, some scientists have documented that it increases stem cells. But once you have released your stem cells, in order to support them, fasting is a good thing. It does release stem cells, but what is, to me, fascinating about fasting, and we go back in this way with one of your earlier questions, what can we do to support the bone marrow? Fasting has shown that if you take a stem cell from the bone marrow and you test its ability to multiply, migrate into tissue, and differentiate, which gives you an overall measure of how good that stem cell is to do its job of repair. If you do this, and then you fast for 3 days or more, and then you take another sample of stem cells, if you take stem cells during the fast, you have more in your blood, but they're almost like dormant, like they're not very effective during the fast. After the fast, when you get into your refeeding period and you look at these stem cells, they look like they have rejuvenated, like they behave like younger stem cells. So the question is open, like, does it last over the long term? But there's good chance that it does. So when you fast, it's almost like you give a rejuvenation boost to your stem cells. So when you release them later on, they're more effective stem cells. So fasting is a good thing to do as you take a product like Stemregen to release stem cells. I would say if you really have something that has been lingering for a while and you want to repair it, a good thing to do could be do a 3-day fast and you follow that with Stemregen. So you rejuvenate your stem cells and then you boost them and you release them from your bone marrow. So these are good things to do. And what we just talked about before, anything that enhances blood circulation, physical activity will push your blood into all parts of your body. So it's a good thing to do. Good sleep will help stem cells migrate in various tissues, but the brain for one of them. So it supports brain repair. To have anti-inflammatory diet. So add a lot of colors into your food. Berries, colored veggies. All of these contains polyphenol, and oftentimes all these polyphenols, ginger, curcumin, turmeric, they all have anti-inflammatory properties, antioxidant properties. So these are a good thing to do. Avoid the stuff that tend to increase inflammation and have a negative impact on cellular membrane. So trans fat, fried food, that kind of stuff. I mean, honestly, almost anything that you know as not being good for your health, you may like the taste of it, but you know it's not good for your health. We've almost like documented that it has a negative effect on stem cells. Alcohol, excessive alcohol, smoking will reduce the stem cell efficacy. So anything you know is not good for health, do it for a while when you're trying to repair. It almost all have an effect on stem cells.
Yeah, good. And coming on to the PEMF side of things. So, our listeners will probably all be PEMF users. They'll have PEMF in their daily routine. Your listeners will be stem cell users and they do that as part of their daily routine. But what's the benefit of them coming together and combining it? I had my experience and now I'm kind of living off the two, PEMF and stem cell therapy.
Yeah.
But what are the potential benefits do you think of the two, and what can PEMF give to someone who's using stem cells?
It's an incredible synergy. I would say if you were to do one thing in addition to PEMF, it would be to take a product like Stemregen Release, to put more stem cells in circulation. And the reasoning behind this is simply that PEMF will do like two main things. Every single cell of the body depends upon a difference of electrical potential between the inside and the outside. So a lot of the energy of a cell is expended by this active process of kicking certain ion out and kicking some ions in the cell, so that there's a difference of concentration of the main ions, which is essentially calcium, potassium chloride, calcium, and sodium. These are the main ions that are segregated across the membrane. And whenever a cell wants to bring in sugar, wants to do something, it opens ion channels and basically use that concentration gradient to drive something across its membrane. It is like the universal energy source of a cell. It's that difference of potential. So if you get a cell that is sluggish, it cannot do that very well. And I think one of the action of PEMF is that when you give these pulse, if you want magnetic shock, you recharge these membranes. So you take sluggish cells and suddenly they're just more effective because they've regained their basic source of energy. And that is why the benefits there are so many kinds of benefits, because a cell that is more effective of any organ and tissue will make that organ and tissue more effective. So it's an amazing approach here for overall health. But if you apply PEMF to a tube of stem cells, like stem cells in a test tube, it tends to stimulate their transformation into bone, ligaments, tendons, things for joints. So I think that there's a reason here, by observing the benefits, why PEMF has been used so much for sports injuries, joint injuries, is that there's an amazing coupling of when you put PEMF alone, what it does, aside from membrane potential, PEMF has been shown, and it could be because it's affecting the membrane potential of stem cells. We don't know. But you start to increase the ability of stem cells to migrate in that area. You've increased the microcirculation in that area, meaning as stem cells are circulating everywhere in the body, you will pull more of them in that area. So suddenly you've brought the repair potential more to that tissue. When they go there, they are more effective in their ability to migrate in that tissue. When they have migrated, they proliferate more effectively with PEMF. They differentiate in cells of that area more effectively. So I would say the other big role of PEMF is that it enhances the repair role of stem cells in an area. So now think about this and simply bring more stem cells in your blood circulation. You suddenly just like magnify the impact of that modality, which is PEMF. So a little bit like, I don't know what would be a good example. I don't have a good analogy that comes to mind, but the power of PEMF relies in its ability to boost stem cell function. Now bring more stem cells into the area, into your blood circulation, and you've just now magnified what PEMF can do. So to me, it's just like, it's the optimal synergy.
Yeah. And
I use it. I use PEMF with I use it. I use yours.
Oh yeah. Yeah. No. So I think you've got Accelerate now, haven't you? So yeah, exactly. It's a great combination. I pretty much think I'm superhuman now after my last healing episode. So, I've been sharing it and talking to a lot of people about Stemregen now too. So one other thing I just wanted to touch on was HBOT, because hyperbaric oxygen chambers are being used more frequently now. And I've heard you talk quite a lot about the synergy of those two therapies too. Can you just touch on, the benefits of using those with Stemregen as well? Yes.
So just like PEMF, hyperbaric chamber or hyperbaric treatment have like two main mechanisms of action. One of them is oxygenation. The amount of oxygen that you can dissolve in your plasma at atmospheric temperature is limited. It's about 3%. And your red blood cells have been designed with this atmospheric pressure over millions of years to basically try to saturate your blood with oxygen in your fine microvasculature. So that way you can feed your cells with oxygen. But if you change atmospheric pressure, you change the solubility of oxygen into your plasma. So if you do enough of these hyperbaric treatments, then you start to boost oxygen in all your tissues and you boost cellular function everywhere in your body. So that's why hyperbaric chamber is so good for various, for a whole slew of health conditions. But it also boosts in that way proliferation of stem cells in the bone marrow. So when you proliferate stem cells in the bone marrow, more stem cells are available for repair. So more of them will leak out of the bone marrow. So you get a modest increase in the number of stem cells in circulation. But if you take Stemregen with it, then now you have more stem cells in your bone marrow and you facilitate that release. So they work really, really well together in synergy. And now you add PMF to it. I mean, honestly, this will be like the superhuman trio. The only little hiccup with hyperbaric chamber is just that it's very expensive to have an hyperbaric chamber at home. So an optimal treatment is probably about an hour and a half. And you need to go to places where they have hyperbaric chamber that will go high enough. You have to go, I think, above 1.2 atmosphere. Ideally, if you go to 2, it's probably ideal. But then you need to have the solid chambers. So you need to go to a center that has these. I'm not saying it's not good if you do the lesser amount, but it's a little bit like PMF. You need to do this for longer periods of time. And so then it's your commitment to travel. And you need to do this many times a week, let's say 3-4 times a week over maybe, I don't know, 8 weeks, 12 weeks. So it's a commitment.
Yeah.
And if you can have this commitment of both time and then cost, then it would be an amazing trio, for repair of just about anything.
Yeah, yeah. And like you mentioned there, a great home care solution to this is, a full body PMF mat that you can lay on, sit on, watch TV 20 minutes a day and 6 tablets of Stemregen every day. So it's an easy combination that you can incorporate into your everyday life. So where do you see the future of stem cell therapy in the next 5-10 years? Is there any kind of major advances that you'd want to see happening?
I mean, there's what I could see happening, but there's also what I would like to see. Well, let's put it this way. What I would like to see happening, but I think it is something that is going to happen. 3 things mainly are going to happen. Number one, I think with these podcasts, with more research, publishing more research, trying to educate as much as possible, the understanding, I think, will penetrate the general population to really understand stem cells is a normal part of your physiology. You can tap in the regenerative power of stem cells right now without having to travel to another country. And that is by itself is going to change a lot. By changing a lot, I think of about, well, if most age-related disease are the result of the decline in the number of stem cells in circulation, and you can delay the onset of these problems by putting more stem cells in circulation, then it goes without saying that if everybody on this planet stimulated the release of their own stem cells, it would completely change the face of the earth in terms of health, wellness, and disease formation. We would have a different planet. So I think that one direction would be to bring that education and give access to a product like Stemregen or these plants, however it works, to bring that knowledge to the general population. So that's number one. Number two, it has already started. We can now take stem cells and tweak them. You can identify genes that have been associated with longevity and insert these genes in one of your stem cells, for example, grow these stem cells into a population, re-inject these stem cells into your body, and now you have a new population of your own stem cells in your bone marrow that now have a new gene that encodes for longevity. So now you're genetically engineered for longevity. That is already happening. There's a clinic in Costa Rica that already is doing this. There's a lot of risk. We don't know if there are risks, but it has not been studied. But that line of work and treatment has started to basically correct your body right now that may have genetic weaknesses, correct that by injecting genes into your own stem cells and basically providing a new pool of genetically modified stem cells in your own body. The other direction would be to identify stem cells that are more potent than umbilical cord stem cells. They are yours, so there's no problem in injecting into your body genes or cells from another individual, and they are just as potent, if not more potent, than embryonic stem cells. Umbilical cord stem cells. And these cells have been identified in the human body. It's just that the method to have access to them, extract them, and grow them is still in development, but there's a point where this is going to come. So we will have access to super potent stem cells. Everybody has them in their body. We can go and remove them, re-inject them. You can release your own so that you take the two together, and then you really boost an amazing power here to repair, so which is going to increase, if not longevity, definitely health span. And if you have really genetic weaknesses, we'll be able to remedy those. I think that in the next 10 years, this is a lot of the direction where this is going to take.
No, I hope so. So we'll leave the link to Stemregen under this podcast. So if anybody wants to, take a deeper dive into that and to start their own stem cell therapy journey, then they can start there. I know you're a very busy man and you're flying all over the place, but if somebody wants to contact you, Christian, how is the best way to do that?
Well, if you go on our website, stemregen.co, you will see that there's an email for customer service, care@stemregen.co. You can go there, drop an email. If they cannot give you your answer, they'll come to me and I'll be able to answer the question. On TikTok or Instagram at Stem Cell Christian, if you put something there as well, it will get to me.
Excellent. So for our listeners, if you can leave us a 5-star review and, like and share these, then we can get more amazing guests like Christian. So thanks for your time today, and I hope to speak to you soon. We'll have to do a part 2.
Thank you very much.